everyone, this is Nusra, the science tutor at Tutopia. Today in this video, we are going to investigate about kinetic energy and potential energy. Let's have a look at the definitions. So the potential energy is the energy that has been stored in an object due to its position, while the kinetic energy is the energy that an object has while it's moving. So kinetic energy can be found in an object when it is moving. If that object is in rest due to its position, the kinetic energy will be stored as potential energy. So potential energy can be converted into kinetic energy, and kinetic energy can be converted into potential energy. When we look about the kinetic energy in more depth, kinetic energy is the energy of motion, as we already said, and the formula for kinetic energy will be half mv squared. And here in this formula, m stands for the mass, v stands for the velocity. So we know that kinetic energy is proportional to the mass. Meantime, the kinetic energy also is proportional to the velocity. And because of this, the faster an object moves, the more kinetic energy it has, because when the velocity increases, the kinetic energy increases. Okay, the more mass an object has, the more kinetic energy it has. That's again is the same thing, because the kinetic energy, it is proportional to the mass. All right, we have got a question. Kinetic energy, okay. According to this equation, what affects kinetic energy more? Is it the mass or the velocity? All right, let's investigate about this question in a clear way, in a clear manner. First, let's check about the mass. And this time, let's keep our velocity to be constant, maybe 3 meters per second. 3 meters per second. But I am going to now double our mass. In this case, let's say it's 2 kilograms, but here it is 4 kilograms. Now let's try finding the kinetic energy in both instances. Here it will be mv squared, that is half mv squared. Half mv squared. This one simply it's half into 2 kg into 3 meters per second squared. And here it's half into 4 kg into 3 squared. So solving this gives me 9 joules. Remember, the unit of energy is joules. Whatever the energy, it can be the kinetic energy, or maybe the potential energy, chemical energy, or maybe the thermal energy, whatsoever it is, whatever the form of the energy, the unit still will be joules, and it is written using capital J. And over here, the answer is 18 joule. So yes, of course, when we are increasing the mass, the kinetic energy increases, but it is doubled. It is doubled. Let's now investigate about the velocity. And this time we are going to keep our mass a constant value. The mass is going to be constant this time. So let's say the velocity here is 3 meters per second. And the velocity here is 6 meters per second. And the mass is 2 kilograms. Here it is 2 kilograms. Now, kinetic energy is half into mv squared. It's here half into mv squared. It is 2 into 3 squared. This is 2 into 6 squared. The answer here is 9, but the answer here is 36 joules, which is 4 times greater than the initial kinetic energy. So which factor, is it the mass or the velocity that affects the kinetic energy more? It is obviously the velocity. Right. Moving ahead, we have a question. So we know that kinetic energy can be observed in an object which is moving. Which of the following has kinetic energy? A book on a shelf. The book is in rest, so it's not moving and it does not have kinetic energy. A girl sprinting, of course, we can go with this answer since we can see a motion there. A stretched spring. So a stretched spring is storing the potential energy due to its position. So yes, that is potential energy. And the next question is, a girl of mass 20 kg, so mass is 60 kg, not 20, can sprint at 8 meters per second, that is velocity. What is her kinetic energy? So it's a straightforward question, just we have to use the formula that we studied, which is half mv squared. So we have half, instead of m this time it's 60 kg. Remember, our mass has to be in kilograms in order to substitute in this particular equation, and when our mass is in kilogram, we have to maintain our speed in meter per seconds. And here the answer will be 1920 joules. A car of mass 1000 and 1500 kilogram. It has a steady speed, has a kinetic energy of 200 kilojoule. Okay, this time the kinetic energy is given, but remember it is in kilojoules. If we are converting this into joules, it will be equal to this particular amount. And what is the speed of the car? So kinetic energy simply is half mv squared. And this time we have got this amount, which is this, and half is here, mass is here, so velocity squared. V squared will be times 2 divided by 1500. So here the answer becomes 266.66. Still, we didn't find out the velocity. What we have found out so far is the v squared. So we have to find the velocity by getting the square root of this, and the square root of this amount is equal to 16.3. Remember, what we are finding over here is the velocity, or maybe the speed. In that case, the unit has to be meter per second. And yes, we have the option, the answer here. A mass of 40 kg and mass of 80 kg. So we have got two objects this time. Both are having different masses. And if air resistance is ignored, which would hit the ground first? This is really easy. We know that the kinetic energy is proportional to the mass. So greater the mass, greater the kinetic energy. The object with 80 kilogram mass is going to have the greater kinetic energy. And now we are finally moving to the formula of potential energy. Gravitational potential energy is equal to mgh, where m stands for the mass, g stands for the gravity, and h stands for the height. And we know the gravity of Earth is approximately 10 meters per second square, and the accurate amount is 9.8 meters per second square. Depending on the question, we can use these one of the values from these both values. So approximated amount is 10 and actual, the exact amount is 9.8. Where does a car on a hill have the most potential energy? mgh is the potential energy, gravitational potential energy, in other words. So potential energy, again, it is proportional to mass, same like kinetic energy. Also, potential energy is proportional to the height. So greater the height, greater the potential energy. When the car is on the top of the hill, the height is greater. So in this position, the potential energy will be greater. What is the gravitational potential energy of 1 kilogram ball? So this time the mass is 1 kilogram and the height is 2 meters. Okay, now we know that the potential energy is mgh. Substituting the values, 1 kilogram, so 1. And for the gravity, that this is 10 and h is 2. So we have to get the answer 20 joules, and the close answer for this is 19.6. And let's see why we do get 19.6. So this is the approximated amount of gravity. If we are using the actual amount, the potential energy will be mgh, m is 1 kilogram, gravity is 9.8, and height is 2. So yes, here we do get the same answer, which is 19.6 joules. If a 2 kilogram rock, now the mass is given, it has the potential energy of 196 joules, and how height is it in? All right. So the question is, there is an object in a particular height. Let's say this is that object, and the mass of that object is 2 kg, and the potential energy that it is storing is 196 joules. Our question is to find out the height from the sea level of this object. Directly substituting it as we were using to do this. So potential energy equal m into g into h. We are going to use 9.8 for our gravity. This is 196 joules. Mass is 2 kilogram. Gravity is 9.8 meter per second square. And h is what we have to find. So 196 joules being divided by 2 into 9.8. The answer is exactly 10. Remember the height, so unit will be meters. We have got another question. Two bodies of equal masses are okay. So this question tells that we have two identical objects, but the height is h and 2h. What is the ratio between the potential energy? So for this, it is mgh. For this is mg2h. So this is 1, this is 2, and yes, we have the answer 1:2. Now we are going to do one more question. And the question tells us we have two objects in the same height. Let's say the height is 8 meter, and the mass of the first object is 4 kilogram, and this mass of the second object is unknown. Let's say it's m, and the question tells the potential energy of the first object, or let's say this is object A and this is object B. The potential energy of object B is this many times lesser than the potential energy of object A. Question is to find the mass of object B. How do we do that? The first thing that we can do is we can find out the potential energy of object A, which is simply mgh. So m is 4 kilogram, height is 8 meters, and gravity is 9.8. This time let's go with the approximated value. And over here, the potential energy will be 32 joules. All right, 4 times lesser, it is 8 joules. Oh, we have to make a simple change in the question. Let's make it half times lesser. So here the potential energy in the second object is 16 joules. And that 16 joules is equal to mgh. M is something we don't know yet. The gravity is 10, height is 8, it is equal to 16 joules. So making the m subject, we have 16 being divided by 8 and 10. If we are solving this, we do get 1/5 kg for our mass, which you can still give as a decimal number. So yes, we have summarized, we have given a summary on kinetic energy and potential energy, the differences, the units, and few example questions are discussed. Hope this is helpful for you, and I hope to meet you guys in another video with a fresh concept. Thank you. Bye-bye.